Cisco Systems dev.
I was going to introduce you.
Oh,
You start?
you can introduce me.
Okay, I'll introduce you.
Yeah.
All right, well, so Warner's already introduced himself, but I was supposed to introduce him. Unfortunately, I was downstairs, and it took some time to walk upstairs. Warner Losh is a member of the core team. As you can see, he also works for Cisco Systems on FreeBSD and other operating systems technologies. There are seats in front. I know no one wants to sit up front. Really. There's at least 10 seats. Okay, I'll start again. So welcome to the first paper, first two papers, but the first paper of AsiaBSDCon 2008. Warner Losh, as it says on the slide, is a member of FreeBSD core, as well as having worked on FreeBSD for quite a number of years. Currently he works for Cisco Systems, working with FreeBSD and other operating systems technologies. His paper is titled Tracking FreeBSD in Commercial Products, and he will now speak to you.
皆さん、こんにちは。私はWarnerのFreeBSD Core と Cisco Systems です。今日、Tracking FreeBSD in Commercial Product を教えます。これから英語で I'll talk in English now. So today I'll be talking about tracking FreeBSD in a commercial product. I'll talk about various strategies that you can use so that as FreeBSD evolves, you can take advantage of that evolution in your product. So what do I mean by a FreeBSD-based product? First of all, most of what I say will apply to any open source product. But a FreeBSD product is any product that includes FreeBSD, perhaps completely unmodified, perhaps just with some configuration, all the way to highly customized kernel with specialized hardware and applications to run, to control that hardware. So to understand how best to track FreeBSD, you need to understand a little bit about FreeBSD's development model. So I'll go into that briefly. Most of you are probably familiar with this. It's a very common model used in most open source software projects. There's a main line of FreeBSD that all the changes go into initially. From time to time, we do major releases from that main line, so we branch a major release, so the number of changes on the branch are much lower. Over time, we fix bugs in the stable branch and do additional releases from the stable branch, and the main line continues on. And the one rule we have in FreeBSD is everything has to go into head or current first before it can be merged back into stable. You'll also see stable referred to as rel-eng some number. So rel-eng 3, rel-eng 5, rel-eng 6. Those are all branches that track the 3.x, 5.x, or 6.x release. So in theory, the FreeBSD project does a new major release every 18 months. We have a branch that's active for 24 months, and the branches terminate after 3 years. So that we typically only have one active branch and one main development branch at any time. with a little bit of overlap while we're doing the first and maybe the second release in a major release. So I drew up a little model of this where you have the main line. This represents change. This is just an arbitrary number of changes to the main line. This represents time. This is in years. So we would be going along, we branch 3.x, work on it for a while, and then stop. At the same time, we're continuing on towards 4, and so on all the way up. Right now we've just released 7.0. This is a nice, pretty picture. If we were to actually do this, it'd be amazing, but reality is somewhat different. The major releases aren't exactly evenly spaced. Sometimes we attack too much technology for a major release. Sometimes we have a release engineer that doesn't drive the release quickly enough. There's a number of reasons why they're not evenly spaced. Also, branches tend to live a lot longer than our idealized model because people are using them, people are supporting them, people keep changing them. The model that I showed had a uniform distribution. The 3.x and the 4.x branches looked the same, but in reality, as you'll see in a second, they're vastly different. And the project freezes the code base from time to time to get some stability in the code. So that also distorts the nice, simple drive towards release with technology. On the average, we kind of match, but I took this graph here is the number of changes in FreeBSD's CVS repository over time as it's going up here with the different releases. And as you can see, there are very long tails on these releases. RelIng 3, the data here is quarterly. RelIng 3 is still getting a commit or so once a year. And that was a branch that was made in 1999. So it's a 9-year-old branch, and we're still having people commit to it. You'll see that 4.x and 6.x have a nice large slope, while 5.x has a slower slope, which means those are more active branches. So when you are confronted with this kind of reality, when you need to track FreeBSD for your products, this might present some problems for a certain class of users. So there's a theoretical product life cycle that pretty much every product follows. And in this life cycle, at least for this talk, you grab all the software you're going to use, you make all the changes, and you release. That's all you ever do. Tracking FreeBSD just doesn't matter because you've just made one release, there's never another one, and it doesn't matter. But oftentimes, you'll make the release, and there'll be bugs to fix, you'll have other customers, there'll be new features you want, and if you're successful, you'll need to stay current with FreeBSD over time, or ignore FreeBSD over time, or something. You need to plan for something. So, when I'm talking to managers, oftentimes they'll say, well, why do you need to upgrade? What is the compelling reason to upgrade? And what problems do you encounter? And the problems you typically encounter when you're upgrading, moving from version to version of the system, are that you've made changes, maybe you fixed a bug, but somebody else has also fixed the bug. So when you go to merge in your changes, there's a conflict. Sometimes if you've written your application to FreeBSD, and let's say it opens a serial port, and the name of the serial port driver has changed, or you're going to new technology, so you've gone from a hardwired serial port to a USB serial port. So there's a number of changes that you need to make as you're changing from version to version to the system, or of the system. The other question I get asked by managers is why upgrade? And the biggest reason that you need to upgrade is new hardware support. Even for people that say, I build this board, I put these parts on it, I have absolute control over this board, you'll only be able to build that board for a number of months or years until some part goes obsolete and you have to redesign it. And usually you can withstand a couple of small redesigns, but eventually enough parts go obsolete that you have to upgrade to the next set of technologies, and you need new Ethernet drivers and so forth. Another reason to upgrade is new features. If you are processing transactions and you're on a uniprocessor machine and time passes, FreeBSD now supports SMP, supports threads. Your programmers want to use these, your customers want to have a smaller footprint, so you want to move to SMP. That's another reason to upgrade. Again, bug fixes, you might hit a bug in FreeBSD that's fixed in a newer version. If you just upgrade, then you won't have that bug. And another reason to continually upgrade is that it keeps you more in touch with the FreeBSD developer community. When you're initially doing an effort to bring up FreeBSD, there's interaction with the developer community, and it's easier to interact with them if you're on 7.0 or 6.2 than if you're on version 2. So one of the experiences that's been repeated in a number of companies, and I'm sure if you work for one of these companies, you think I used you as an example. This is actually a composite of several. They import FreeBSD, a particular version, they start hacking on it, they completely ignore the community, they do their own thing, they wind up being successful, and then all of a sudden they need to upgrade because of the reasons I outlined earlier. They need new hardware, they need new features, and it becomes a major porting effort. There's a lot of pain and suffering involved when that happens. And with a little bit of forethought and a little bit of work as they go along, they could have avoided this. So how do you avoid this kind of bad experience with FreeBSD or NetBSD or whatever product that you're tracking? Chances are your products will use FreeBSD and other open source packages in different ways, some of which you'll want to track in one way and some of which you may want to track in another. If it's something you just drop in and use, you may just want to go the grab it from the vendor and upgrade route. If it's something that you modify heavily, then you need to be more involved with the community developers that surround you. The other thing that you need to do, in addition to staying current, is feedback changes into the community. Typically, bug fixes are not a competitive advantage. People don't need, you're not going to make a better router if you have fixed a bug in Live C. It's just something that everybody does and everybody needs, and whether you have that bug fixed or not, you're not going to sell more hardware. So those are some of the things that you can do in general. So what are the tracking options that you have with FreeBSD or any open source product? Well, the first one is grab it and forget it. This is a very common model that leads to the bad experience that I referred to earlier. In this model, you grab the source and then go about your merry way. Don't worry about it. The second option is grab and upgrade. If you are running a stock FreeBSD system, it's a name server or a web appliance or something, maybe you can use FreeBSD as is, in which case you would grab the releases and you would upgrade from time to time whenever there's better performance. A lot of companies, though, need to make tweaks to FreeBSD or the open source system, and they're unable just to run the stock systems. So they need to track changes to FreeBSD. And there's a couple of ways to do that. The first way is, since FreeBSD creates stable branches from time to time, those are an excellent source to track. They have bug fixes done to them regularly. They don't have disruptive changes made, or new features typically, and they're relatively easy to track. There's some disadvantages with this approach also, but I'll get into those here in a minute. The other way that companies have used is to mirror FreeBSD's development process. And briefly, with that, people import FreeBSD current into their own current tree. They make all their changes in their current tree while they keep importing new versions of FreeBSD. And when they feel the tree is stable, they make their own stable branch. This has the advantage that you don't have to wait for FreeBSD to branch a stable release to use it, but there's some disadvantages with that as well. And the last item on this list is very closely related to the first item on the list, because if you grab FreeBSD and become successful and need new features, then it becomes a major upgrade operation. And for some people, maybe that's worthwhile. For other people, maybe not. Okay, the grab and forget or grab and upgrade model is very simple. I've talked about it. You get it, you use it, you don't worry. The advantages to this approach is that it's easy and simple. You bring in the code, you're done, you explain to management, hey, I'm going to do this, you do it, you're done, you don't have to schedule any ongoing time for anything. This approach works really, really well when you don't have a large number of changes, or you have very few changes that you need to make to a piece of software. And you don't have to interact with the community. Some open source communities can be difficult and time consuming to interact with. But the disadvantages of this approach, if you do have a lot of changes, upgrades can be difficult. And it becomes difficult to add and keep local changes to the software that you're doing. The other problem with just the grab part, if you grab and never upgrade, is FreeBSD is really good technology, but one of the things that makes FreeBSD good technology, or NetBSD, or any of the other open source projects, is that they continually are refining the project. They're continually adding new features, fixing bugs. And if you never upgrade, you don't get any of that benefit. The other problem with this approach is that hardware changes over time. And you need new drivers to support the hardware. Maybe you need new technologies like ACPI to even configure the hardware. And if you've never upgraded, you're stuck with older hardware, which you might not be able to make anymore. It might become too costly to build. It might not give the performance that your customers need. And even though I said it was an advantage that there's no interaction with the community, it's also a disadvantage. You don't learn what features are coming along the pipe in the project that you're tracking. You don't build a rapport with developers. You can't leverage them to help you fix your bugs. They don't know what you're doing, so they might do something that is against your best interests, something that would make your product more difficult to do in the future, not because they want to make your life difficult, but they have a number of choices to make. They arbitrarily pick one in the absence of information. Had you been involved in the community, a different choice may have been made. But again, if you are doing the grab and update, then some of the disadvantages go away. So for things that are lightly changed or not changed at all, this can be a perfectly adequate way to track source changes. The next approach is an approach that I took at a company called Timing Solutions. I worked there for 8 years, and we delivered probably 20 or 25 different products, all based on FreeBSD, either 3.x, 4.x, 5.x, and 6.x. So we spanned 4 major releases doing this approach. And the approach is fairly simple. When FreeBSD creates a rel-ing branch, a stable branch, you grab that at a point that's convenient, and import it into a local source control module. In CVS, we just made a separate directory for each major branch that we use. We then would make the relatively few number of changes that we needed to make to that branch. We would make the bug fixes that we wanted to merge upstream to that branch, and then we would use the source code management tools diffing abilities to generate diffs to see what changes would need to be pushed upstream. Because when we got into a release cycle, we were very, very busy, and then afterwards we would have time to do this. And sometimes the SCM acted as our kind of institutional memory. So we would remember that we made these changes, and we would need to go out into the community and push these changes back into the community. And what I've drawn here is a graphical representation of it. The black is FreeBSD, the different branches in FreeBSD, the mainline development, and then the different major branches. The green represents tracking, represents the source code repository that the company keeps. So here, there's an import from FreeBSD 7.0 into the company's 7.0. We called ours, we had a 3-letter acronym, TSC. So it was TSC4, TSC5, TSC6 that we checked it into. And then this shows that additional polls are coming from the FreeBSD repository. And I made the slopes of these lines a little different. This is a little sharper slope than this to indicate maybe that this lags a little bit in what it's doing. That also gives you the ability to control when you pull this in. If, for example, 4.8 turned out to be a really bad release, you could skip it entirely, or you could defer and keep going with what you had before, just pulling in critical fixes with this. This isn't an all or nothing pull as well. One of the things I haven't drawn on this chart because it made it too complicated was then if I had a fix here, it would go back to current and then back to here, and it was kind of hard to draw that so that the rest of the chart still remained viable. And you're always able to get a diff of this branch and this branch, either directly through the SCM, or you just check out the last version that you checked out of CVS from FreeBSD, grab your version in the SCM, and run the diff command. There's a lot of ways that you can implement this. It doesn't really matter which source code management tools you use. So the advantages of doing this approach is that you get bug fixes from FreeBSD. That's the primary thing that's going into the FreeBSD stable branches, are bug fixes for the stable technology. It becomes easier to push changes upstream because you have a small delta that you can run diffs with. The diffs, the patch sets become manageable, and it winds up working really well, particularly if you have a FreeBSD committer in-house who can push things into the repository. If you don't, it still works out fairly well because when you produce small diffs and small patch sets, it's relatively easy to get those integrated into FreeBSD and usually other open source projects as well. The advantage that you get from doing that, taking the time to do that, then is you get a lot more eyeballs looking at your fix. Maybe you think your fix is good, but other people might not think so. Or other people might see problems in it that you overlooked. So the fixes that come back from FreeBSD that you've integrated into FreeBSD oftentimes come back with a higher quality than your internal programmers were able to do alone. The disadvantage of this approach is if you find yourself using multiple branches, the changes don't automatically propagate. So if you've made changes to FreeBSD 4 and you pull a FreeBSD 5 tree and start doing this, only the changes that you add to that tree will be there. So that is a lot of extra work, or sometimes It's just work that's not done, and you forget about the bug fixes that have happened. Depending on the size of the uncommitted bug backlog that you have in your stable branches, that would make this harder to do. Now, it's also an incentive for people to push changes back into the tree to keep those deltas smaller. The other disadvantage of this approach is what I was referring to earlier, is that FreeBSD, all changes go into current first and then into stable. And if you are touching some code that has had active development in it, it can be harder to get that patch, which is good for stable, into FreeBSD because it has to go through current first. So that can also be a problem. The final disadvantage of this approach is that the FreeBSD major releases, or any open source project's major releases, with maybe a couple exceptions, are unpredictable. If you want to ship product based on technology you know is in FreeBSD current, but don't want to ship a current branch, you basically have to wait to ship that product until FreeBSD does their branch, or you have to go and do the work of backporting that technology to the stable branch that you have. So for some situations, this might not work well for people. And those are the sorts of situations where it wouldn't. The other process that is used by a company that was acquired by Cisco, that uses FreeBSD extensively, is they maintain their own version of current that they pull changes into all the time. They make sure that their product works both on current and on the stable branches they create. They create stable branches when they want, not when FreeBSD decides that there should be a stable branch. The advantage of this is that, and they push the changes back early and often. They spend extra effort to make sure that any changes that they make to FreeBSD that are relevant to the community get committed quickly, so they get peer review, and so that the delta between their FreeBSD current and FreeBSD is just the changes they want to be in there, the ones that they're not giving back. So this is a slightly more complicated chart, which shows the merging back and forth between the main development branches, and it shows the pulling the stable branch at some point that's not when FreeBSD does its stable branch. And again, I've omitted merges from FreeBSD here and from the on the company's repository here just to simplify this chart. The advantages to this is that merging becomes very easy and very simple. You have a very small delta between your code base and FreeBSD's code base. You have incentive to proactively push changes upstream. You get the reviewed changes downstream, or coming back to you fairly quickly. And you can also find problems with the changes that people make to your changes quickly as well, because you're running your product both on the FreeBSD, on your company's current branch, as well as the stable branch that you use for production. You have much more involvement with the community, even though some communities can be difficult to work with. In general, most of the open source communities are relatively easy to work with, and you benefit greatly from being involved with the open source community. People know you, people are more willing to help you when you do have problems if they see that you're active and pushing changes, pushing bug fixes back into FreeBSD. The other advantage of this approach is that you get to choose when you do the release. You get to choose when you create your stable branch. And you don't have to wait for FreeBSD's release process to happen. This can be, typically, since we've gone to using perforce for the major disruptive changes, FreeBSD current is relatively stable most of the time, and you could pull a stable branch at relatively any time. Now, of course, there are exceptions to this, and you need to be aware of that. And that's actually one of the disadvantages, is that if people make large destabilizing changes to FreeBSD and you pull those in, you're not going to be able to do your stable branch at that point. The other disadvantage to this approach is that your stable branches get less testing than FreeBSD's stable branches. There's a lot of people that run FreeBSD stable. There's a lot of effort that goes into making sure that bugs are fixed in it, that it's a reliable system that you can use. If you do your own version of stable, you don't leverage the developer community and user communities to do testing for you effectively. The other problem is that you have to convince management, hey, I need to do this work twice. No, you're not really doing the work twice, because you do the main work on FreeBSD current, and then you do a little extra work to backport it to your stable branch. But managers hear that and they think, oh, that's twice the work. That's crazy. That's not very efficient. Why would I sign off on that? And it takes some education of your management, and it takes management buy-in to make this an effective model. The other problem is if you're running your own crazy version of stable, at least in the community's mind, it becomes difficult to get help from the community. Gee, it sounds like you might be experiencing a bug that I think we may have fixed 3 months ago in this thing that you pulled 6 months ago. Might be a typical response, which isn't definitive and isn't always helpful. It might show you where to go look for your problem, it might not. So you get really a mixed bag of results when you go with this approach. So I was expecting this to be translated, so I only prepared a half hour. So is there any questions I can ask? Anything you'd like me to talk about at this point? I put a copy of my paper at this mural, except there should be a 2008 right here. It wouldn't fit on my slide when I had that there, so I took it off, but then I copied it to the wrong place. So, are there any questions, anything I can answer? Okay, thank you very much.
So we're done a little early. Lunch will be on the second floor, for those of you who didn't hear the announcement, starting in... Lunch starts at 11:45, so in about 15 minutes on the second floor. そしたら2階でお昼ご飯は11時45分から